Hello friends, just before this I have given so many videos on chapter 1 solid states. Now today's video is on magnetic properties of the solids. Now in this video I will give you a clear concept, very simple concept to understand it. Now, magnetic properties of solids. Solids possess magnetic properties. Why? What is the reason behind it? These magnetic properties of the solids is due to magnetic moment. And this magnetic moment is caused by the charged body electrons. It is actually due to electrons. And electron is a charged body. This is charged body. And the electrons, it possesses motions. It means electrons, it possesses motions. And due to these motions, these possessed motions are of two types. One, that is the orbital motion, and other is spin motion. First is orbital motion. You see here orbital motion and spin motion. It means due to orbital motion and spin motion, the solids possess magnetic moment. And due to motion of the charged body, that charged bodies possess current. And that current causes magnetic effect. In orbital motions, see here, you see the diagram. Suppose this is the nucleus, and this nucleus, around this nucleus, the electrons revolve. And this magnetic moment is produced by the motion of the electrons. Electron revolve around the nucleus. It is an electric loop, just like an electric loop, and it possesses the magnetic moment. And electron not only revolve around the nucleus, not only show the orbital motion, it also shows spin motion. Suppose, see here, this is the nucleus of an atom, and electrons that revolve around it, this possess orbital motion, but this electron also moves on its axis. One clockwise and other is anti-clockwise. This electron will also show spin, because on these orbitals the electrons that will move like this, clockwise and anti-clockwise. And due to this spin motion and orbital motion, the solids that possess magnetic moment, and due to magnetic moment, the solid shows magnetic properties. Now, on the basis of the effect by the external magnetic field, the substances solids are classified in different types. See here, on the basis of the effects, see here, effects, on the basis of magnetic effect of magnetic field, effect of magnetic field, magnetic field. The solids are of different types. That's first type, that is diamagnetic. Diamagnetic solid, diamagnetic substances or solids. Now, in diamagnetic, what happens actually when we apply magnetic field just near the substance? This substance is weakly repelled. It means weakly repelled by magnetic field. Magnetic field. If magnetic field is applied, the substance that will weakly repelled by it. It is caused, what is its reason? It is due to completely filled orbitals. It is due to completely filled orbitals. Completely filled orbitals. It means the orbitals are completely filled. And in orbitals, the spinning of electrons is clockwise and anti-clockwise. So it poses net magnetic moment is equal to 0. So such substances are called diamagnetic substances. As for example, suppose sodium chloride. See here, in sodium chloride you see there are 6 chloride ions that surround sodiums, and just around chlorine there are 6 sodium ions. So their charges are being cancelled. Its magnetic moments becomes 0. Potassium chloride, water, benzene, etc. These are actually diamagnetic substances. Now the next type that comes in, the paramagnetic substance. Now the second type is paramagnetic substances. In paramagnetic substance, just opposite of it, it is weakly attracted by the external magnetic field. In it, the electrons in an orbital remains unpaired electrons. Unpaired electrons in orbital. That causes net magnetic moment. It means their magnetic moment will never be 0. It would be always greater than 0. Then such substances are called paramagnetic substances. As for example, suppose oxygen, copper, Cu2+. See here, there is one unpaired electron. Fe3+. There are 5 unpaired electrons. Chromium 3+. This is also the paramagnetic substance. Along with this, that is titanium oxide. This is also paramagnetic. And also we can say here Ti2O3. etc. These are paramagnetic substances. Now the third is ferromagnetic substances. Now in it, this is not weakly, strongly. We can use here strongly attracted by the magnetic field. And in it, what happens? Why it is strongly attracted? Because it is highly paramagnetic. It means highly unpaired electrons. Electrons. That causes the magnetic moment would be higher. And in this case, we see here, in absence of magnetic field, applied magnetic field, then the substance possesses permanent magnetic behavior. This permanent magnetic behavior of this ferromagnetic substance is due to the domains of electrons in the directions of the magnetic field. Due to this parallel or domains that shows unidirections. So unidirections. See here, in this case, if you see here the diagrams, then what happens? This is like this. This is all the domains, all the electrons that will move in one direction. So this behaves as a permanent magnet. But actually, what is domains? It means in this substance, the smallest part, that is called atoms, molecules, ions. So that smallest part, see here, the smallest part, suppose this is substance, the smallest part of this substance, atoms, have the common spinning of the electrons. Suppose these parts have the common spinning of the electrons. And these are actually assigned in a small region. This is a small region, so these parts behaves as a tiny magnet. All these parts behaves as a tiny magnet. So this part is called domains. When we apply the magnetic field, suppose magnetic field is applied, all the domains starts to spin in the direction of magnetic field. These actually domains moves in the direction of magnetic field. in the direction of magnetic field. So this shows magnetic behavior. Magnetic behavior. On removing this magnetic field, if it is removed, then the spinning of the electrons, all the domains will remain assigned in one direction. So it behaves as a permanent magnet. As for example, if you here iron, cobalt, nickel and alloys alnico. Now chromium oxide, etc. These are the ferromagnetic substance. Now in this case, this actually acts as, it is used in magnetic tape. Magnetic tape for cassette recorder. For cassette recorder, this CrO2 is used. Now the next is the fourth, that is antiferromagnetic substance. In this substance, antiferro, it means the domains are aligned opposite to each other. In each domains are aligned opposite to each other. See here, domains, this is opposite to each other. That causes magnetic moment is zero. Such substances are called antiferromagnetic substances. As for example, this will call MnO, MnO2, Mn2O3. These substances are called antiferromagnetic substances. Other examples are also here. Now next, that is the ferrimagnetic substance. In ferrimagnetic substance, here the domains are aligned opposite to each other. Domains are aligned opposite to each other. But condition is unequal in number, parallel and anti-parallel. It means that would be opposite to each other, parallel to each other, but unequal in number. See the diagrams. See here, one is this. These are anti-parallels. Suppose this. See here, in this case. See here, these domains are opposite to each other, but their numbers are unequal. That causes magnetic moment. Its magnetic moment will never be zero, because this is cancelled, but these two will give the magnetic moment, so its magnetic moment would be greater than 0. As for example, in it is Fe3O4. woodsite, and also ferrites M2 plus, that is Fe2O4. Fe2O4. See here at example Fe2O4. In this case, this M must be the divalent metal, and such as magnesium 2 plus, zinc 2 plus, etc. So such substances are called ferrimagnetic substances. And now, what is the effect of heat on these substances? If you apply heat on it, that at a particular temperature, that is Curie temperature. See here, effect of temperature on magnetic nature of substance. See here, that is antiferro, that is ferromagnetic, and we can say here that is ferrimagnetic. We give a particular temperature, that is particular temperature, that is Curie temperature. These substances changes into paramagnetic substances due to randomness of the spin of the electrons. Due to randomness of the spinning of electrons, spinning of electrons. So this video I am given you the concept of magnetic nature of solids, and it is very easy for you, and you will watch it, and if you like or you feel it is good, you will like, subscribe, it's your. Just after this I shall give you some videos in Hindi also. Thank you and have a nice day.